Hello everyone and welcome back to the GCSE Maths series. Today we're going to be looking at simultaneous equations. So let's get straight into it. So by definition, a simultaneous equation is when you have two or more equations with two or more unknowns. At this stage, we're only going to look at two equations with two unknowns. If you go into A-level maths, is when we'll look into having three simultaneous equations with slightly more unknowns. So we're going to use a method called the elimination method, which is used to solve the two simultaneous equations by eliminating one of the variables. And in this case, the variables are x and y. X and y. So we want to find the values of x and y, and we do this by adding or subtracting the equation so that one variable completely disappears, allowing you to have an equation with only one unknown, so that we can answer it. So let's draw out our first one. We have 2x plus 3y equals to 18 and 4x plus 3y equals to 30. Let's call this equation number 1 and equation number 2. So when the equations have the same addition or subtraction, if they have the same operation being applied, so in this case we have positive, so a plus, we minus one equation from the other. In this case, I'm going to do equation 2 minus equation 1 because the answer to equation 2 is larger than the one for equation 1. So I want to get a positive answer once I conduct my minusing. Now, we can do this because our 3y's are equal, meaning when we conduct 2 minus 1, we're going to have 3y minus 3y in our operation. So this is going to give us 0. Hence, y's will completely cancel out, giving us an equation solely involving x with a number. So we can equate x to a number to solve for x to obtain the value of x. Okay, let's do this. Equation 2 minus equation 1. So 4x minus 2x gives us 2x equals to 30 minus 18 is equal to 12. Now this is a standard equation that we've seen many times before. And what we do is we divide through by 2 to get x alone by itself on one side of the equation. So x equals to 6. Once we have our value for x, we take one equation. I'm going to take the first equation, so equation 1. And we have 2x plus 3y equals to 18. We now know a value for x and we plug it in by applying this operation here. And now we can solve for y. So this is 2 times 6, which is 12, plus 3y equals to 18. Let's get the numbers on one side and the y's on one side. We do this for y, minusing 12 from both sides and get 3y is equal to 6. To get y alone by itself on the side of the equation, we divide through by 3 and get y is equal to 2. Hence, the answer to this question is x is equal to 6 and y is equal to 2. We can also further verify this by plugging our values of x and y into the second equation. So 4 times by 6 add 3 times by 2. And we can say this is 24 and this gives us plus 6, which is equal to 30. And as you can see, this matches up with this answer here. Okay, moving on to question number 2. Question number 2, we have 3x minus y equals to 7 and 2x plus y equals to 13. So this is equation 1, this is equation 2. Now if we look at the operation being applied to our y's, we can see that there are different operations. So in this case we do number 1 add number 2, because when we do minus y plus y, this is going to cancel out our y's to leave us with an equation solely with x. And just for your own understanding, we don't always have to cancel out our y, we can cancel our x's first. But as you can see here, our y's make it easier for us to cancel, as we don't have to do any multiplications to make y's the same. The y's are already the same, so we can just continue on from here. So doing this, we get 3x plus 2x equals to 5x. Our y's cancel out, and we get 20. Then, dividing through by 5, we get x equals to 4. Now, taking equation 2 and saying 2x plus y equals to 13, we then plug in our known value for x and get 2 times by 4 plus y equals to 13, which is 8 plus y is equal to 13. Then we minus 8 from both sides to get y alone, and we get y is equal to 5. So x is equal to 4 and y is equal to 5. Now, again, we can double check our answer by saying 3 times by our x is 12 minus our y gives us our 7, which is exactly what we see in equation number 1. Okay, moving on to some harder questions. Okay, so now looking at our slightly harder questions, we can see that we have 6x plus 5y equals to 4.5, and 3x minus 2y is equal to 9. You may have noticed in the previous question where I mentioned we don't have to multiply our y's by anything or our variable by anything. As you can see in this one, none of the variables match up to the variable in the other equation. 6 does not match up with 3, and 5 does not match up with minus 2. Hence, we're going to have to do some multiplication. So, let's call this one equation 1 and this one equation 2. We're going to have to times our equation 1 by 2 and times our equation number 2 by 5. And this is going to create a situation where we line up our equation 1 and 2 so we can cancel out our y's and form an equation solely with x and a number to solve for our x. So what we do is we times everything in the top equation by 2 and times everything in our second equation by 5. And this, you will see, will help us to eliminate our y. So this is going to be 12x plus 10y is equal to 9. Then we have 15x minus 10y is equal to 45. And we add these two to get 27x. Our y's cancel out, it's been eliminated, and we get 54 here. Dividing through by 27, we get x is equal to 2. Now, we pull out another equation, one of the equations from above. Let's say equation number 2, the original one, and we say 3x minus 2y is equal to 9. Plugging in our known value for x, we say that 3 times by 2 minus 2y is equal to 9. Now 6 minus 2y is equal to 9. Now, what we do is we move our y's onto one side and our numbers onto one side, so we get minus 2y is equal to 3. Then we realize that our y is being times by minus 2, so we divide by minus 2 on both sides to obtain our y. So we get y is equal to minus 3 over 2. And this is our solution, as well as x is 2 to our harder simultaneous equation. Okay, now looking at question number 2. We notice once again that none of our variables match up, so we're going to have to conduct some sort of multiplication. Let's call this equation 1 and 2 again. Let's times the top equation by 3 so that we can eradicate our y's. Once again, I'd like to reiterate, it does not matter to eradicate the y's at all times. What I'd just advise is pick one where it's easiest to find a variable which you can eradicate. In this case, I'm only going to have to times the top one by 3, so hence it's the easiest step to make. So timesing equation 1 by 3, we get 9x minus 3y is equal to minus 12. Now rewriting equation number 2 underneath, we get 2x minus 3y is equal to 9. Now the signs of our y are the same, so we minus them to cancel out, because minus 3 minus minus 3 will result in minus 3 plus 3, which is equal to 0, hence it will cancel out. Minusing these two, we get 7x is equal minus 12 minus 9 is equal to minus 21. Hence, x is equal to minus 3. Plugging back in, I'm going to rewrite the first equation now and say 3x minus y is equal to minus 4. Plugging in our known value for x, we say that 3 times y minus 3 minus y is equal to minus 4. So minus 9 minus y is equal to minus 4. Putting the numbers on one side and the letters on one side, we get plusing 9 on both sides, we get minus y is equal to 5. And then we times through by minus 1 to get y alone by itself. So y is equal to minus 5. And this is our solution. X is minus 3 and y is minus 5. Okay, so that's going to conclude today's revision video. Hope you guys learned, hope you guys enjoyed the video. As always, please make sure to like, comment, and subscribe. Leave your comments below, and I'll catch you guys in the next video. Peace.